Okay, in this video, we're going to go over the shapes of arithmetic sequences versus geometric sequences, because they do have a very different and distinct shape, and you'll need to know what those are. So for this video, we're going to go over we're going to use the questions in your lessons. So I'm going to use this one for the arithmetic sequences, 1, 3, 5, 7, and so on. And then for geometric, I'm going to use this one, 1, 3, 9, 27. So those are the ones we're going to use. So I'm going to graph them. We know that the way sequences work is we have to identify what order they're in, right? Because if I mix these up, it's a completely different sequence. So this is the first number, second number, third number, fourth number, and so on. So the way I'm going to represent that on the graph is with a coordinate. So for example, the first number being 1, I'm going to represent like this, 1, 1, meaning the first number is at 1 right here. Okay, so the second number is going to be 3, and that's how I'd represent it, 2, 3. The third number is 5. Okay. And the fourth number is 7. And we could go on. Hopefully you can identify the pattern at this point in talking about geometric sequences, that the common difference in this sequence is 2. So then if we wanted to continue, the fifth number would be 7 plus 2, which is 9. So hopefully you're able to see that pattern at this point. I'm going to go ahead and try to fix some of these here. I want these to be the same color so that you can kind of see what I'm doing. And we're going to compare them to the arithmetic sequence. Okay, so the arithmetic sequence will be in black, and the geometric one will be in a different color. Okay, so that's the first one. And I want you to kind of notice what shape these are in. These are in a straight line. We call that a linear shape when they're in a straight line. If you've plotted a arithmetic sequence correctly, it should be a straight line. And then now we're going to go over to geometric. So the same kind of idea, but we're using a different kind of sequence altogether. So the first number is 1. Okay, same as before. And then the second number is 3. And then already you can kind of see that there's a difference here. The second number, oops, that's supposed to be a 2. There we go. All right, so the second number is 3, just like before. And then the next number is 3. The third number is 9. Okay, and again, I'm getting that just from right here. That's the third number, and it's 9. And as you can kind of see, that third number is a lot different from the third number in the other sequence. It's clear up here versus the other one was right here at 5. Okay, next is the fifth number. It's going to be, wrong one, fourth. The fourth one is 27. Okay, and geometric sequences are new to us, a little bit more new than the arithmetic sequences. But in this one, the common ratio, is 3. So to get the next number, we would just multiply 27 by 3. But that's already off my charts, so I'm not going to plot another one. But I am going to change these colors so that you can see these are all from the exact same graph. Okay, now if I go through, and I'm going to just see if I can hide these guys for a second. Let's look at the geometric sequence. If you can see, it starts off real small and then gets big really, really fast. And then like we talked about, to get the next number, you would need to multiply 27 by 3, which would be a very large number. So that would be really, really far up there. So hopefully you can see that this shape here is exponential. It starts off very small and then gets big rather quickly. So that is kind of what I want you guys to see, is that arithmetic sequences are linear, they make a straight line, and geometric sequences are exponential, and they are shaped like an exponential.